In this video we are going to study gravitation. This is a 9th class NCERT chapter 10, and let's go through it. We always observe that an object dropped from a height falls towards the earth. We know that all the planets go around the sun, the moon goes around the earth. In all these cases, there must be some force acting on objects. The planet and the moons. The planet and on the moon, Isaac Newton could grasp that the same force is responsible for all these. This is called a gravitational force. In this chapter, we shall learn about the gravitation and the universal gravitational law. What is a gravitation? Let's discuss this. The change in the direction involves change in the velocity or acceleration. The force that causes this acceleration and keeps the body moving along the circular path is acting towards the center. This force is called centripetal force, meaning center-seeking force. What is the tangent of a circle? If a line touches a circle and which makes a 90 degree with a center, this is called a tangent. Motion of a moon around the earth is due to centripetal force. The centripetal force is provided by the force of attraction of earth. Which attraction? Gravitational attraction. There is no such force. The moon, if there is no such force, if there is no gravitational force, the moon would pursue a uniform straight motion. Suppose this is a earth and moon is rotating around the earth in this way due to centripetal force, and this centripetal force is coming due to the gravitational force. If there is no gravitational force, there will be no centripetal force, then moon will be like go in a straight line, uniform straight line motion. Newton concluded that not only does the earth attract an apple, and the moon, but all the objects in the universe attracts each other. This force of attraction between the object is called gravitational force. So it is happening in all types of forces, in all types of objects in the universe, not only on apple or home, but all the objects in the universe. All the objects, suppose two persons are there, between them there is also a gravitational force. Man and a tree also have a gravitational force. Every object experiences this force and attracted each other by this force. Although we cannot feel it because it's negligence, but it is always there. What is a universal law of gravitation? Every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of distance between them. So this is the product of masses. This is m1, m2, and the product of masses will be small n, and this capital M and small n. Product of masses and square of distance between them. Distance is d and square of this. So this comes to the F equal to, F is directly proportional to the force is directly proportional to the product of masses upon distance, square of the distance between them. And the proportional signs when it changes into equal, the new things come which is constant. A G is constant, where G is a universal gravitational constant. Let's read about the Isaac Newton. Newton formulated well-known laws. This guy was from England, and formulated well-known laws of motion, worked on theories of light and color. Great mathematician, and invented new branch of mathematics called calculus. And he transformed the structure of the physical science, and his three laws of motion, and with his three laws of motion and universal gravitational law. How did the Newton guesses the universe square rule? By the Kepler's laws. What are the Kepler's law? There are three laws of Kepler's, and the orbit of the planet. First law of Kepler is the orbit of a planet is ellipse. It's not a circle. It is a elliptical, egg-like, oval-like, ellipse with has a elliptical orbits with sun at its foci. This is a ellipse. Foci is these are the foci. And the line joining, the second law is the line joining the planet and the sun sweeps the equal area into equal interval of time. So this concept is very important. Line joining the planet and the sun sweeps equal area. Suppose this is a sun and this is a planet, and this line join this covers equal area and equal interval of time. Suppose this area is one. Suppose this area is suppose 1 meter per square. Just suppose it, and also it takes a time of 1 second. Also here this area is 1 meter per second, and it also will be covered in 1 second. So from distance here to here in 1 second is less time, less distance, and here the distance is more. That means here the speed will be slow and speed will be fast. This is an important concept. When the earth is far from the sun, its speed is slow, and when it is near, as it has to sweep the equal area in equal interval of time, it will definitely, the speed will be faster. This is what the concepts this second thing says. Okay, and the third is the cube of mean distance of planet. Mean distance of planet from the sun is proportional to the square of the orbital period. Okay, this is important. It was the Newton who showed that the causes of planetary motion is the gravitational force that the sun exerts on them. The Newton used the third law of Kepler to calculate the gravitational force of attraction. This law was used to calculate the gravitational law of attraction, and the accepted value of G is 6.673 into 10 to the power minus 11 Newton meter square kg minus square, inverse square. So how the inverse square works? If the d, which is a distance between the two objects, gets bigger by a factor 6, the force become 36 times smaller. This is a d square, no? It is a d square in between. If the, like, suppose 1 meter is there and force is suppose 1000 Newton between them. If the distance increases by 6, now it is 6 definitely 6 meter. the force will be automatically, because it is like it is a square, so the force will be 36 times smaller. What is the free fall? Whenever an object falls under the earth, falls towards the earth, this force alone under whenever objects fall towards the earth under this force alone, under which force? Gravitational force alone, we say the object in a free fall. So suppose this is an object and this is the earth, and there is no other forces, so under the influence of gravity, if some object is falling, and this is called a free fall, and this motion will be accelerated motion of an object, and it accelerates due to earth gravity, which is 9.8 meter per square acceleration. It accelerates. This is how we find the capital G. Universal gravitational constant is this, and this is how we find it. The value of the acceleration due to gravity on earth is this. Acceleration due to gravity on earth is 9.8 meter per second square. And this is the derivation how we found it. What is the mass and what is the weight, and what is the difference between them? Mass is a mass of an object is a measure of its inertia, and this is based on inertia. We have also learned that the greater the mass, the greater is the inertia. It remains the same wherever the object is on earth, whether the object is on earth, the moon, or even in the outer space. The mass remains the same. Thus the mass of an object is a constant and does not change from place to place. What is a weight? We know that earth attracts every object with a certain force, and this force depends on the mass of an object, and the acceleration due to gravity, which is a G. The weight of an object is the force with which it attracts towards the earth. So mass is comes in an object due to the mass of its constituent particles, atoms, molecules, and all that, where the weight comes due to mass and the force of attraction which pushes a particular object under the influence of gravity. Suppose on earth we have a gravity, and the gravity the value of gravity is 9.8 meter per second square. This is how it gives acceleration of 9.8 meter per second square in every object. So the weight is the force which is applied on this object by the gravity. So this is what it is written. So the force which is ma, so weight is equal to the force, and force is equal to ma, mass into acceleration, and acceleration is 9.8, and mass of a body is this. Suppose someone is 98 kg, okay, and 98 kg, kg, someone weight is 98 kg. We can calculate its mass by dividing it by acceleration due to gravity. So it will come about 10 kg will be its a mass, while 9.8 will be its weight. So 9.8 is a bit hard to calculate, so we just take a 10. So suppose someone is like 50 kg and its mass will be 5 kg. If someone is 60 kg, its mass will be 6 kg. So this is how the mass and weight is, and remaining 6 kg is there, and remaining 54 is the force of attraction due to the gravity on him. And this is a comparison between the mass, weight of an object on the moon and weight of the object on earth. This is because it is weight is 1 and mass is 6. Why it is? Because the moon has a low gravitational attraction, which is 1/6 as compared to the earth. What is a pressure? Pressure is a thrust upon area. Pressure in liquids. Now we are discussing pressure. Pressure exerted in any confined mass of a liquid is transmitted undiminished in all directions. What is a buoyancy? Buoyancy is a upward force exerted by the water. It is but water exerts an upward force on a bottle. Thus the bottle is pushed upwards. When the force due to the gravitational attraction on the earth attracts the bottle in downward direction, so the bottle is pulled upward. When the bottle is immersed, the upward force is exerted by the water on the bottle is greater than its weight. Therefore it rises up when released. Simply, the buoyancy force is the upward force exerted by the water on the bottle is known as upward or buoyant force. And the magnitude of this buoyant force depends on the density of the fluid. What is Archimedes' principle? It is similar to buoyancy. The principle says when a body is immersed fully or partially in a liquid, it experiences upward force, which is the buoyancy. That force is equal to the weight of the fluid displaced by it. This is a 10 kg 10 kg block, and when it is this bucket is filled with water, completely filled with water, and suppose the block is dropped. Now few water drop spill out. Suppose the 3 liter of the water spill out. Suppose let's do it in kg, not in liter. And the weight of this will become 7 kg if is measured here. So this is what when body is fully immersed, it experiences the upward force. It will, so it is originally a 10 kg, it will, the 7 kg is there, only 7 kg remains, so like the 3 kg, it is upward force. There is a upward force of 3 kg here, and which is equal to the weight of the fluid displaced by it. It displaced the 3 kg. So this is how what Archimedes principle says. It becomes 7 kg from the 3 kg. Why? Because it displaced 3 kg of water, 3 liter actually, but the consider is a kg, 3 kg of water from it. The mass reduced, if the mass reduced of an object is equal to the weight of the water displaced by it. And how much water it can displace? It can displace water which is equal to the volume of this. The Archimedes principle has many applications. It is used in designing ship and submarines. A lactometer, which uses to determine the purity of the milk, and hydrometer, used in determining the density of the liquid, are based on the Archimedes principles. What is a relative density? The density of a substance is defined as the mass per unit volume. This is a unit volume. Suppose this is a unit volume. 1 unit, 1 unit, 1 unit. It has a 1 unit like length, breadth, and height. So the mass per unit volume is density. Suppose its mass per unit volume is, this is a 2 unit cubes, and its mass is 20 kg, and its mass is 50 kg. So this has more mass, so this will have a more density. This both are unit cube. Suppose this is 1 centimeter cube, and this is also 1 centimeter cube. So the density depends upon the mass per unit volume. The relative density of a substance is the ratio of the density, the ratio of its density and to the mass. If you compare the density of any object to the density of water, which we consider 1, then we call it relative density. So the density of substance upon the density of the water. Density of a mass we take, density of water we take 1, and suppose the density of a substance is less than 1, it will float on the water. If density is more than 1, which is more than the water density, then it will shrink. We have let's wind up this chapter by revising it quickly. The laws of gravitation state that force of attraction between two objects is proportional to the product of their masses and inversely proportional to the square of the distance between them. It is directly proportional to the masses and inversely proportional to the square of distance between them. Such law is said to be universal. It works in every planets, stars have this force of attraction between them, which can be measured by this formula. Gravitation is a weak force unless the large mass is involved. This is why it is weak for stars. They are very far away from each other, so their distance is very far, and when we square the distance, it becomes a huge number. So the gravitation force is almost negligible, and also although the gravitation force is also a weak force. Why it is weak force? When we compare with this other types of force, we have electric force and magnetic force, electromagnetic force is one, and nucleic force is there. There are 4 fundamental forces are there that we will study in 11th class. When it's compared to that, when we will compare, gravitation is the weakest force in nature. The force of gravity decreases with the altitude. On earth, it is talking about the earth. It also varies on the surface of the earth, decreasing from poles to equator. So let's also understand this. This is the earth, so this is the equator. So gravitational force in equator is less, and at poles it is more. Why it is less at equator, although it has a similar should be similar attraction force? Because the earth is almost spherical. So it is because at the radius it rotates this way. So because of center, it has a high centripetal force. It has a high velocity. The object is moving high velocity due to its high centripetal force. The it feels more weightlessness compared to compared to an object located in this region. So due to due to there is a more speed in equator. The weight of the object is the force with which the earth attracts it. This is the weight, and mass is comes from the inertia, from the mass of the atom, mass of the molecule, and all that. The weight is equal to the product of mass and acceleration due to gravity. Mass, product of mass and acceleration due to gravity. I just have explained this. The weight may vary from place to place, but the mass stays constant. All the objects experience a force of buoyancy when they are submerged in a fluid. An object having a density less than the density of liquid in which they are immersed floats on the surface of the liquid. If they have a density less than 1, they will float. If the density of an object is more, that means more than 1, because one density water has one density. If the someone density has more than 1, it will immerse it like the density of the liquid, then it will, when it is immersed, then it will shrink in the liquid. When object having more density than liquid is immersed in the in a water, then it will shrink. It talks about the liquid only, it's not talking about the water, it only talks about the liquid. So in conclusion, the densest liquid settle down at bottom, and and the low density low density liquids remains up. This is what the concept says, and here ends this chapter. Thank you for watching.